Hello, darlings. After suffering a mild heart attack looking at these here results from the quiz of 5, as I thought, simple questions, I have decided to give you another tutorial. Hopefully it will help. And by the way, the person who finally got an 80% took several tries. When you take several tries, I see that you do it, so don't do that again. So, Newton's second law, one more time. We're going to look at your first fan cart lab. Here's a setting where we have this cart loaded with 3 fans and only one of them is on. And when you ran it, you saw that the acceleration was 0.4 meters per second squared. Then you turned on both fans. The third one was still off. And what you saw was that acceleration went double. It is 0.8 now meters per second squared. And that is because the force doubled. When you tripled the force, the acceleration tripled. So that was fine. Your understanding of the concept is fine. You know that if the force increases by a certain factor, acceleration will increase by a certain factor, providing that the mass remains the same. Now, when you dragged these little puppies onto the cart, then you saw that with the same number of fans, if you double the mass, acceleration is half. If you triple the mass, the acceleration you can predict will be 1/3 of what it was before, when there were no masses in the cart. Now let's look at this situation. We have 3 fans on, but one of them is opposite. Remember when you gave your cart a certain velocity of 2 meters per second, and you turned 2 fans on, one was to the left, one was to the right, acceleration was 0. And that was because the 2 forces were acting against each other and somewhat canceling each other, and therefore there was no acceleration to speak of. Here, we have 2 fans to the right, 1 to the left. It's the same as if you just had 1 fan on and it was to the right. Because let's say this is 2, that will be 4, and that will be -2 because it's acting against them. So 4 minus 2 is 2. It's as if there was only 1 fan. Now, when it came to simple calculations, when you were given a force, you're given a mass, and you need to find acceleration, you were seemingly fine. So let's look at this. Let's draw a free body diagram. So here's my box, which represents the cart. I'll start with the first force, which is force of gravity. It's always there. And the opposing force, sort of a reaction force, if you will. We call it normal because it's perpendicular to the surface. So that normal force is equal to force of gravity, counteracts it, sort of canceling it. Our object is not going to be accelerating, falling through the floor, or jumping off the floor. Our cart is in equilibrium, meaning that the forces are equal and our object is not accelerating up or down. And then we had the force of the fan, and I'm saying that it amounts to 12 newtons. So providing the cart has a mass of 3 kilograms, then I can easily calculate the acceleration. So acceleration equals force over mass, force being 12 newtons and mass being 3 kilograms. That gives me 4 meters per second squared, and you remember acceleration is measured in meters per second squared. Another example, what if I am given the mass and acceleration, but I need to find the force? It's still just one force, so it's fairly simple. Force equals mass times acceleration, mass being 5, acceleration being 3, 5 times 3 is 15, you remember that? So 15 newtons is my answer. The force provided by these fans is 15 newtons. What if I need to find mass? Let's say I know that the force is 200 newtons, acceleration is 4 meters per second squared, but I need to figure out what kind of an object this is, what mass this object has. Well, in this case, I'm going to use acceleration formula, but I'm going to tweak it just a little bit. So here's what I do. Since mass is in the denominator, all I do is I flip or switch these two, mass and acceleration. So acceleration will go down into the denominator and mass will be freed into the real world and will become just the number. So mass will be force over acceleration, or force divided by acceleration. Force being 200 newtons, acceleration being 4 meters per second squared, we end up with mass of 50 kilograms. Now, trouble started when we had more than one force. So let's say, like here in the picture, I have one force pointing to the right and one force that is less pointing to the left. My free body diagram now will have one more force, and it's going to be to the left. So let's say force 1 that is to the right is 200 newtons, force 2, which is to the left, is 50 newtons, and the mass is 30 kilograms. How do I find acceleration? The formula is still the same. The only difference is that now it's not just any force. I cannot just take 200 newtons. I cannot just take 50 newtons. They work together. So I have to find the difference between them, and that will be my force that I will plug into the acceleration formula. 200 minus 50 is 150, Hence, I plug in 150 and I divide it by mass. 150 over 35 meters per second squared, and that's the answer. And I'm thinking that this part you still could do, because it's pretty easy to see. Force 1 to the right, force 2 to the left, they kind of work against each other, subtract one from the other. Hooray, we can do it. When I asked you to find one of the forces, that's when Armageddon happened. Why? I am not sure, but hopefully after this tutorial, this type of question will give you no trouble. It's still the same formula. We still have the same diagram. Force to the right, force to the left, gravity and normal are taking care of each other. They don't even play any role in our equation here. 200 newtons is the force to the right. And I know that there was something taken off from the 200 newtons. So what I'm going to do, I'm going to look at the same formula. Force 1 minus force 2 is what gave my 30 kilogram object a 2 meters per second squared acceleration. So I'm going to multiply. That will be my 60 newtons. And what is my 60 newtons? That's the difference of these two forces. So force 1 minus force 2 is indeed 60 newtons. So if I know that, and I know what this is, that's 200 newtons. So then 200 minus something equals 60. Simple algebra, 200 minus 60. I rearrange this formula and it will give me 140 newtons. So the force pulling to the left was 140 newtons. Again, 200 minus 140 gave me 60, which is mass times acceleration. Neither of the two forces gave it acceleration by itself. It's when they worked together, when force 2 took away from force 1. That's when they were able to give it 2 meters per second squared acceleration. Another example. What if I give you F2, the opposing force, and I'm asking you for F1? The same type of problem. Again, we start with force over mass equals acceleration. Mass times acceleration is, in this case, 90. And 90 would be the difference between these two forces. So then force 1 minus force 2 equals 90, and my force 1 is greater. So basically force 1 is greater than force 2 by 90 newtons. So if force 2 is 100, then force 1 was 90 newtons more, which is 190 newtons. So look through this as many times as you need. Repeat it if you need to. Follow through, take notes. Don't just stare at it, actually write it, because it helps you. Your muscle memory will be always with you. And then retake that quiz and please make 100. Thank you.